or what in origin of life studies became known as self-organization. In a crystal of salt, there is a force of attraction, a chemical force that is responsible for the beautiful ordering of the crystalline structure that you often find with salt. The idea that was first put forward, the first self-organizational theory, was put forward by a man named Dean Kenyon and his co-author Gary Steinman in a book called Biochemical Predestination. The idea here is that you've got forces of chemical attraction that are responsible for the sequential arrangement of the amino acids that allows the protein to fold into its right structure and perform a function in the cell. There was also the hope that perhaps this idea could be applied to explain not only the sequence specificity in proteins, but also in DNA and RNA as well. Well, it turned out that this model unraveled, and the chief architect of the model himself ended up repudiating his own theory. But I want to zero in on the problem of trying to explain the origin of information in DNA by reference to any kind of self-organizational forces of attraction. This is, you might recognize, a magnetic chalkboard. This is a little metallic chalkboard, and there are magnets in the back of these letters. So there are forces of attraction, forces of necessity, if you will, that explain why the message sticks to the medium. Now that's exactly the same, that's exactly what's going on in DNA. There are forces of attraction that explain why the message sticks to the medium, but those forces of attraction do not determine the arrangement. I can destroy this arrangement and make another one very easily, okay? So let me put it to you now, maybe as a rhetorical question. Was the message I had at the beginning the result of the magnetism? Okay, that's the key point. The point I'm making about the DNA is that the arrangement of the bases, which constitutes the informational endowment of the DNA molecule, is not the result of the chemistry attraction that holds the chemistry of attraction that holds the molecule together.